Welcome back. Here we are still on page 8 of your trig packet 1. We're talking angles, and we're not only talking angles in degree measure, but we're getting back used to radian measure as well. And we're going to talk about ways that it can be even more useful than degree measure. I just got cut off on problem 10. The bottom line here was you can still do the conversion to radians in the same way you did 6 through 9 here. But this one's kind of a cumbersome measure. I'd say it would be fine to just approximate here and use the pi key in your calculator. Let's see what happens when we try converting, radians to degrees. Now, I know that this time, right, we wrote down the conversion that when we were going to radians, we multiplied by pi over 180. Well, here I want to multiply by the reciprocal of that. I want to multiply by 180 divided by pi. A way to remember it, right? In general, you don't see degree measures too often that are in terms of pi. So a good way to get the pi's to cancel with one another would be to have the pi on the bottom. And then work on your reducing skills, right? You don't have to reach to a calculator for this one. You could say this denominator goes evenly into that numerator. 3 goes into 180 60 times, right? Leaving me a 2 times a 60. An answer like 120, it's a good answer. But if you leave it like that, you can't get full credit. You mean for your answer to be in degrees, so let's put the degree sign on it too. Here's where it comes in handy. I would say you're going to do the same thing for the next 4 questions. This would be a good time to just pause the video and try to do the conversion on your own. So if you could take a couple minutes to try 12 through 15, and we'll use a calculator for maybe the last 2 of those, and then maybe tune back into the video, you can check your answers. So we'll pause. Back again, I saw 12 and 13 weren't too big of a deal. I got 150 degrees and 135 using the same exact method. Then I get to 14 and 15. 14 just gave me a pretty big degree measure. The pi's cancel. And then 8 times 180 ends up being 1440 degrees, which is an acceptable answer, right? That demonstrates that 8 pi is going around the circle, full revolutions, once, twice, 3 times, 4 times around the circle. But this might be a good instance to bring in a coterminal angle measure that's a lot smaller. So an angle that's going to land in the same spot, but it's a lot smaller. And maybe since you see that this is it's a direct integer multiple of 2 pi, that our final answer is going to be 0 degrees here. 0 should be coterminal with 1440. Now, why is that? I got to think back to my skateboarding days. So 1 revolution's a 360, 2 is a 720, and then the last one I have off the top of my head is 3 360s. In the skateboarding world, we would call that a 1080, I believe. And that gets you down to 360 degrees. And if so that's a good coterminal estimate as well. That's going to fall in the same exact spot as 0 degrees. So both of these give you the same angle. They represent 2 different amounts of rotation. For 5, I would go to a calculator. I think I just did for this one. I'd type it in, using the pi key, 4 times 180 divided by pi that you see here. And we'll see this is going to be a quadrant 3 angle. And we'll just round it. Use the calculator, we'll say 229. And then I think it was like 0.183. Don't forget the degree sign on all these answers. So it's really good to know how to convert back and forth. Second thing, what if we don't always want to have to convert back and forth? We want to be just as comfortable drawing and placing angles in their correct quadrant, whether they're given in degrees or radians. So I wanted to look at the next page where we are challenged to sketch a few angles in standard position. And these are given, the first ones are given in radian measure. In standard position, we know an angle has 2 sides, an initial side that's going to be along the positive x-axis, and a terminal side. And you guys are lucky. I'm not going to be too picky about how this angle looks, but I am going to be picky that it falls in the correct quadrant. So you got to think to yourself, it's probably past quadrant 1, right? 2, if you wrap 2 radii around the circle, kind of like we did on the last page. But I don't think it's much past quadrant 2. Think about it. You've got, all the way to here would be pi radians. Pi is about 3.14. So 2 is much less than that. Let's think about half pi. Half pi would only, if you estimated it, it'd just be around 1.57. So we're going to go past half pi, but not past a full pi, not past quadrant 2. As opposed to 4 radians. 4 radians takes you a bit further, right? You're at 0 radians, we could say here. I'll say RAD. You've got about half pi, 1.57. An estimate here is about 3.14. But then look, if we added a half pi to that, that only gets us up to about 4.71. So this will land the initial side, positive x-axis, terminal side, not past 4.71. So we've got a quadrant 3 angle, right? You're just estimating where that should fall. What about the others? 5 radian should take me to quadrant 4, right? Initial side here, not quite to double pi, 6.28. So 5 radians, you've got your amount of rotation represented in that arrow. We're going to be in quadrant 4. These are big ones too. So 5 pi over 3, get used to 5 pi over 3. Multiples of pi over 3 are special angles. They're going to be coming up a lot in trigonometry. This is where I like to just count thirds pi. Basically split up the circle into pieces of PIE, pieces of pi. So think of 1/3 pi, right? Here's 0, your initial side. 1/3 pi would be 60 degrees, right? 1 pi over 3 would be right in quadrant 1. Can you count yourself up to 5 pi over 3, right? Would be a way we could draw this angle without having to convert it to degrees. Here's 2 pi over 3, right? That's going to be equivalent to 120 degrees. Here's 3 pi over 3. That's a full pi. Almost a 5. Here's 4 pi over 3. 4 pi over 3. And finally, we've counted our way all the way to 5. Let me make this bold. 5 pi over 3, all the way into quadrant 4. Now, sure, I'm going to admit it too. You could just do the conversion pretty quickly and see that that's going to be, I believe, 300 degrees, right? We would know that's also in quadrant 4, but you don't really have to think about it that way. You kind of visualize the circle there and just split it up into fractions. Let's try a few more of these. Can we try 7 pi over 6? Right? We know pi over 6 is a small little angle of 30 degrees. That would be 1 pi over 6. We got to get ourselves up to 7. Well, think about it. If you did 2, 3, 4 pi over 6, what if you got all the way up to 5, 6 pi over 6? This would be a full pi, a 6 pi over 6. And we just have to go 1 pi over 6 past that. 7 pi over 6 takes you to where 210 degrees would fall, right? A quadrant 3 angle. We can count quarters pi, right? 9 pi over 4 takes you even more than, I think, a full revolution around the circle. Here's 0, your initial side. Here's 1/4 pi, 2/4 pi, 3 pi over 4, 4/4 pi, right? It's kind of fun. You have to admit 5 pi over 4, or yeah, 4 pi over 4, 5 pi over 4, almost lost count. 6 pi over 4. 7 pi over 4. Here's 8 pi over 4, which is just 2 pi. And then 9 pi over 4 has taken us back to that 45-degree angle. So your rotation is going to be a full 8 pi over 4, a full circle around, and then all the way back. All right, so it's a good skill to get back used to radians and be able to sketch angles that are given in radian measure. And you can go back and try 22 and 23 as well. But if we're going to get used to converting back and forth and just being able to handle any angle measure that's thrown at us, I wanted to play a little game here with some important angles around this circle. And now what do I mean important angles, right? Special angles that show up a lot in trigonometry. We've mentioned already in degree measures the quadrantals. So 0 is a quadrantal angle, 90 is a big one because it separates quadrant 1 from 2. 180 is one that is spoken of a bunch, as is 270. And then full circle, we've got 360 here. Also in degrees, could you go in, I'm going to fill out quadrant 1, but then I want you to see what else you could fill out around the other quadrants. So 30 degrees, if I split the 90 into thirds, you'd have 30, then 60, then 90 degrees, with right in between 0 and 90, a 45-degree special angle showing up in the middle. Could you figure out kind of like their associates, I guess you could say, in the other quadrants? So if I went, this is 30 degrees to get you to 90. If I went 30 degrees past 90, I'd be at 120, right? 90 plus 30. If I went 15 degrees past that, right, I'm at 135. And then 15 more degrees past that, another special angle is going to be what? 150 here. Could you continue the trend, pause the video real quick, and fill out the angles that are kind of related to these in quadrants 3 and 4, adding 30 to this one, getting 210, and then continuing. So I'm going to pause here and do the same as you, see if I can fill out some others. So I'll pause. I'm back now, so you can check out the other degree measures that we filled in around the circle. And then also I had to go above and beyond. You know I'm getting to this point. I also want to fill out the special radian measures that are equivalent to those degree measures, but I'm not interested in every single time having to do the conversion by multiplying by pi over 180. So now I filled out the quadrantals, right? We've seen these already today. 0, half pi, pi, and then 3 pi over 2 down at 270. Can we do the same thing just as an exercise with these other special angles? So we've counted quarter pies before, right? 1/4 pi is 45 degrees. 2/4 is up here. Here's 3/4 at 135. 3 pi over 4. Let's finish the quarters. 4 pi over 4. Here's 5 pi over 4 at 225. And then 6 pi over 4, and then we've seen 7 pi over 4 at 315. But for fun and for completeness, I definitely use that term fun loosely here. Could you fill it out for the 30 and 60 degree special angles? Keep in mind that 30 degrees is equivalent to pi over 6. And if you double that, right, if you go pi over 6 and then pi over 6 again, that gets you up to 60 degrees. So that'll be 2 pi over 6 or pi over 3. Keep on going with that. Each time you move 30 degrees, that's just like adding pi over 6. So here's 2 pi over 6, 3 pi over 6. This 120 should be 4 pi over 6 or 2 pi over 3. If you could pause the video one more time, just for practice, could you keep on filling out the missing radian measures around the circle? Here's where I'll pause one more time. Okay, I'm back. And this, if I do say so myself, is now a thing of beauty. You've got degree measures all the way around all 4 quadrants of those important special angles. And now you can see that we've filled in their radian measure equivalents. Check over everything, make sure you agree with what we wrote there. And I'm hoping this becomes very, very visual, where you're not constantly having to find yourself scrambling to multiply by pi over 180 to get those conversions. But you're kind of visualizing, okay, where should, if I added a few quarter pies, where would I fall and what quadrant would this angle be? Lastly, because coterminal angles come up so often and because finding them sometimes makes our job easier with a lot of these questions, I think it's a good way to end the session. So looking at 24, you have a task to do. It says find 2 coterminal angles, one with a positive measure, one with a negative measure, both in radians here, for the angle. So we got to think back to what coterminal meant. Coterminal angles, they land in the same exact spot. They look exactly the same. They have different amounts of rotation. 2 pi can really come in handy here. In degrees, right, adding or subtracting any integer multiple of 360 is a good way to get a coterminal angle. Likewise, when we're working in radians, adding or subtracting any integer multiple of 2 pi can come in handy. So what, if 13 pi over 6 is looking like it's more than once around the circle, maybe I'd be okay just subtracting 2 pi from that. And the angle would still fall in the same spot, but I'd have a more reasonable radian measure to think about. And what, 13 pi over 6 minus 12 pi over 6, because that's what it would be over 6, is just going to leave you with 1 pi over 6. So it's much simpler to just say, hey, I'm talking about a 30-degree angle. I'm talking about a pi over 6 angle here when I say 13 pi over 6. To finish the job, we need one negative coterminal angle. No problem. We could subtract the 2 pi again, should get us into the negative measurement. And what? Pi over 6 minus 12 pi over 6 gets you down to negative 11 pi over 6. An angle that falls in the same spot, but the rotation is the other way, right? It's going to be clockwise instead of counterclockwise. Let's end on something quadrantal like pi. Do the same exact thing. This shouldn't be too bad. To get a coterminal angle that's above pi, whoops, I'm thinking 3 already. I'm jumping the gun. So I could add 2 pi to that to get something coterminal and get myself all the way up to 3 pi. Lands in the same spot, different amount of rotation. Counts as coterminal. Take pi, can you subtract 2 pi from it? Pi minus 2 pi will get you a coterminal angle with a negative measure. So in radians, we could say what? Negative pi here also falls in the same spot. All right, it is always a pleasure to talk trig or talk radians with anyone, so it was been fun to talk to you. Enjoy your day and happy practicing. Talk to you later.